This is the video for CS 121, Chapter 6. We are learning functions, and if I look back to a place where we kind of know where functions are, if you're looking at a calculator, each one of these buttons has a little program behind it that makes calculations. Like the sine of x, we wanted to do the sine of 3 pi maybe, second pi. That's not going to a table and looking up something. It's actually calculating what that would be with a little algorithm in the calculator. So you want to think of these functions as like you're creating a little button to make some kind of calculation somewhere. So the general idea here is that we want to reduce redundancy. If you have something that's being done over and over again, like in the main program here, we have 3 times we're calculating an f1 minus 32 times 5 divided by 9, going from, it looks like, Fahrenheit to Celsius degrees. So every time we copy and paste it or retype it, we risk making more errors in our program. It also looks pretty cluttered because over and over again I'm putting the same stuff in. So it ends up making it look a lot simpler if we're just calling a function here to calculate values. So that's one of the reasons we want to go to functions. So our basic function is to set up, it's called a def, D-E-F, that's a definition of the function. Notice that it has a colon after it, and then the rest of the function is indented. Because Python is functional programming, you have to define your function before you actually use it in the code. So you make your function, this whole thing from the def down to all this blank spot is part of the function. So you make your function and then you call it. So the call is to actually use the print pizza area, just like that. You're going to call the function and it goes to that function and then does the lines of code. So as you're going through the program, it'll real quick go past those and then execute this line of code. So it doesn't execute anything in the function until you call it. In the participation activity 6.1.5, when we're calling, we actually define the function here and we call the function way on down here. So the first thing it's going to do is print say cheese, and then it'll print face, which means it goes up here and calls the function and goes through and executes all the lines of the function. Then it comes back to the main part of the program. So they want us to print this star pattern twice. So the solution is real simple. It's just print it twice. So I'm going to call the function print patterns with the parentheses. You have to have the parentheses, and then you're going to do it again. So if I run this, I should see that it prints exactly what I've been asked for it to print. So it prints the double star patterns, or like this says, the hashtags if you enter a different character. So I need a DEF with a space, and I'm going to call it print shape because that's what I'll be wanting to call in a moment. So its name is print shape. I'm going to be calling it with print shape with open parentheses. Now you could do a do loop in here to get all these stars, or you could just type stars, but I did want to show you that if you did print and then put a star in parentheses, and then multiply it by 3 times 3, that'll give you 3 stars. It's not necessary here, but it's something to think about, so you don't have to have a loop if you're going to go across and print stars. I did it with loops every time in the previous chapter because we were studying loops at that time. So I want to print those shapes out. So I'm printing shape, and I wanted to print it 3 times here. So I want to call that print shape to print the below shape example output. So there we have. So either I could call print shape 3 times, or I want it to print out 3 times. So here, if I wanted to print out 3 times, then I'll do for I in range 3, and I'll need this indented. So if I run this, passed all the tests and it printed out exactly what I expected to print out. So they told me they just wanted to make the definition. I needed 3 lines of stars. I could have put that a lot of ways, but I did want to show you this, that if you wanted a whole line of stars, you can tell it how many. So it could have been that you wanted 5 or 6 stars there, and you will multiply by 6, or you wanted to go down, you wanted to have 6, 5, 4, 3, 2, 1, and then you'd be multiplying by different numbers down. I am really guilty of using the words parameter and argument interchangeably. So if I get these wrong, I apologize ahead of time. But they're kind of the same thing because the parameter is a function input specified in a function definition. So the parameter here is pizza diameter. And I oftentimes will call that argument. So if it's in the function definition, it's a parameter. But if it's an argument, if it's a value provided during the function call. So down here when we say print pizza area 12, that's the argument. And I've got those backwards several times. So if you get those backwards, I'm not going to be too specific about it. But sometimes I ask you what the arguments are versus the parameter. So the argument is being sent and the parameter is being picked up. So then the pizza parameter is a parameter within the definition of the function here. We can also have more than one parameter. You could have a whole list of parameters here. But anytime you call this print pizza volume function, you have to have as many parameters as what there are in the list of, as many arguments rather, as what there are in the list of parameters for the function. The challenge activity 6.2.2 is really just a unit conversion activity. So we're given a number of minutes. So that means we want to get rid of minutes and change it to hours. So I want hours in the numerator, minutes in the denominator. So my conversion is 1 hour is 60 minutes. Hours in the numerator, minutes in the denominator, because I want to get rid of minutes. Number 6.2.3 challenge activity is just another conversion, but here we're going to be we'll need to add together the feet and the inches once we've converted the feet to inches. In addition to having parameters in your function, you could also return a value if you wanted to return a value to the main part of the program to use it in some other function or some other code. So if you just supply a return statement like this one, instead of printing, it's going to return this back to be the value for computed square 7. So num squared will end up being compute square 7, which is 49 in this case. The 6.3.3 activity is about valid arguments. So when you're calling, so they give you the definitions here for the function. So we have two different functions, and they want to know which one of these are valid. You can always put a number in. You can't say that z is equal to something that you've called. This is written backwards. In mathematics, this would be fine. In code, it isn't. So you can't do the square root and then assign it to something. You have to say what you're going to be assigning to it and then call it. In this case, the square root function has a parameter, so you have to put an argument in. So you can't do just the square root. You can just call it and have it not do anything, so that's okay. And you can assign something else added to it, and that's all right too. So here they just want to know whether this was valid. Could I do this? If it's valid, you'll say true. The 6.3.1 temperature conversion is just asking us to fix a little bit of code, so you can see some question marks in here and some hashtags that might need to be taken out. So I'm going to do the minimal to this. I want to take centigrade to Fahrenheit, so that means I'm going to need to put a C in here. And it could be any C. It doesn't have to be capitalized. Actually, Python prefers that you don't capitalize. Because I'm going to copy this, I'm going to go ahead and capitalize it, Control C. And put this on my fix me. So F is equal to C times, I don't need the times, the X, I need a star, and the rest of it looks fine. And then I'm going to return my Fahrenheit. So there's my whole function. Don't overthink these. That's all it says. Use this formula and return Fahrenheit. So my temperature C is going in. My temperature F, it says, is none, so I can assign it to no value at all. And then I want to call it. So here I'm just going to take out this hashtag. So temp F, I want to get rid of these two and call that function. So C to F. But I'm not calling it over C because capital C here is a local variable to this function. So my C is actually this temp C. So I'm going to call it for that temp C, and then I want to print it out. I just need to get rid of a couple of hashtags and a space and run. So enter temperature in Celsius, and then that was 50, so Fahrenheit is 122. It didn't say to go to the next line, but I can see here I might have wanted it to go to the next line. So I might have put in a /n here. And it runs it on 2 lines. So there's a hierarchical function calls or nested function calls. So you want to make sure that you have your definitions put in the correct order. So down here, the pizza calories is calling this calc circle. So you want to define calc circle before you do the definition for pizza calories. It's using that within its function. They make the remark that int input is actually 2 function calls. So we're not doing anything different than what we've done before. We're within a function, we call another one. For the 6.3.3 challenge activity, we want to define a function called pyramid volume. And we want parameters in here, and they tell us what to call them. There's no and in the list of parameters. And we begin our function, we need a colon. So you're going to put the relevant geometry formulas into this function, and you'll be able to call this function with the length, width, and height. And there it is. So there's only a couple of lines of code that you need to add to this. 6.4 really is very helpful to those of us who have had programming languages before, because some other languages have heavy types, so you'd have to declare variables, and your functions would have to be able to add variables that are just integers or concatenate strings, where a polymorphic function allows me to change the type that I'm using and still use function. So Python is a little bit more versatile with the functions that way. But if we're adding numbers, this just adds 2 numbers together, x and y, x plus y. And I'm thinking numbers really heavily here, but I could also add 2 strings, which would be concatenating. So they put one right after the other. So take a good look at this, because the polymorphism that we can do in Python is very helpful, because you don't have to write a bunch of separate functions to add different kinds of things. Dynamic typing means that it's happening as you're doing the function. Static typing is what we're used to seeing in C, C++, and Java for a lot of us. So static typing means that you have to declare what type of variable you're using to be able to use a function. We don't have to do that in Python. This idea of dynamic typing is called duck typing. If a bird walks, swims, and quacks like a duck, then call it a duck. That's how Python is going to determine exactly what they should do with your functions. One of the other reasons that we want to use the user-defined functions, these def, and then the functions afterwards. So that would be my first function. There's another function here. There's 2 different functions in here. Is that it makes it easier to understand what we want in the program. So this program says I want some steps. I'm going to take those steps and convert them to feet and print them out. I'm going to take those steps and convert them to calories and print them out. I don't need to know the nitty-gritty details of how I'm doing that conversion in order to understand what this program should be doing. The details are essential, because then you actually do get the correct numbers out. Usually software is written in developmental teams, and the modular development allows different software engineers or programmers to develop the programs in pieces. So it's important to be able to take it apart and test things separately and run the program separately from the rest of the code. You also want to avoid rewriting redundant code. So if you're doing something over and over again, you don't want to keep writing the same code for that behavior being used over and over again. In the challenge activity 6.5.1, they give you a program that they want you to rewrite using functions. So basically, you're putting all the calculations in one place, and then you're going to spit out, and they tell you what the function should be called. They tell you what arguments you're sending to the function, so you get an idea of which one of these calculations you should be doing where. Zybooks has actually set up your programming in incremental development format. So you do part of it and you test it and you get points, and then you do another part of it and you test it and you get some more points. So we're already doing incremental development. Pairing that with modular development, you get a pretty solid idea of how software engineering is done. We also need to know about function stubs, which are function definitions whose statements haven't been written yet. So if we just write a stub in here, so down here, this would be a stub. We can return pass. Well, actually pass, it's not really returning, but it's probably expecting to have a return here. So when we do the call to steps to calories, we're putting in steps. So we're actually putting in an argument. It's being caught by the parameter, but there's a pass, so it's returning pass to calories. So here, calories is not getting anything put into it, so it's none. So you could set up all of your definitions like this, function definitions, with a pass and then start filling them in. So your program will run. It may not give you the results you want in the format that you wanted at the end, but it will run and you'll be able to see how it's working. This says that the function contains a single pass statement because at least one statement is required. So this is important. At least one statement is required in any user-defined function. So pass would be a pretty easy one to fill in to make sure that the program's going to run correctly. Another stub that you can use is put a print statement in that says fix me and return some value that's not going to be useful to your program, perhaps. It's like a sentinel value. So that's another stub. So by stub we mean a program part that needs to be fixed. So you have some way to indicate that it needs to be fixed. So putting pass, putting in a print statement saying fix me with a return that's not really something you want to see, and then doing a not implemented error. So here it's raised and not implemented error, and it's going to give you a traceback. So in 6.6.1 challenge activity, they're wanting you to practice making these stubs. So you have two functions, get user num and compute average. Compute average has two parameters here, arguments here, so we know we're going to need parameters there when we write the function. And all they want in the function is the fix me, finish, get user num. They want the average to be -1 when you send it back. I like to think of the function as like taking a detour in your code. So you want to do these things, but on the way to the store, you realize that you need to stop and get gas, so you stop and get gas, and then you go to the store. So I think of it that way. So anything I do in a function is stuff that I could do in any other part of the programming. So we're just writing code here. Anything that you can do in just a regular block of code, you can do within the confines of a function. In 6.7.1, pay particular attention to how things are defined in the order. So first they say size is equal to 5. So something is going to be set at 5 for everything in the program. So if size is being used within one of the functions, it will be 5. Then they define a couple of functions. They define get nums, they get print all numbers, print odd numbers, print negative numbers. The actual program is there. So there's the main part of the program, the body of the program. And all of the functions that are being used within the body had to be defined first. Notice that size is being used as an argument. So size equals 5 was defined at the top. If it wasn't used anywhere else in the programming, size could have been defined later on after the functions, but size equals 5 so it's defined at the top. Oftentimes, parameters like this, values like this, that are going to be permanent through the entire program are defined at the top. In the 6.7.2 challenge activity, they want you to define a function, print popcorn time. So that's going to come up here in numbers 1 through 3, lines 1 through 3, with a parameter of bag ounces. So inside the parentheses goes bag ounces. Now bag ounces in the function is the parameter, but in the program itself, in the main part of the program, user ounces is the argument that will be sent to the function. So these are two different ones. One's a local and one's for the main program. If bag ounce is less than 3, print too small, greater than 10, print too large, otherwise compute. So you just have an if-else structure in here that's pretty quick. End with a new line. When you make a function, the function is an object. And as part of the value of the function, you're compiling bytecode that represents the statements to be executed. So bytecode is a low-level operation. So they show you the bytecode that you would generate here. It used to be really important when computers were a lot slower that you were fully aware of how much your bytecode was and how expensive it would be to run your function like this. All Python code is compiled before being executed by the interpreter. So if you're doing line-by-line coding, it compiles it immediately and interprets it. If you look through this carefully, you can see the order that things are compiled and interpreted when you have a function. So functions have some common errors that you want to look for. If you wanted to create functions that are very similar, like the Fahrenheit to Celsius, Celsius to Fahrenheit, there's going to be a little difference in the way that they are done. Here, the problem is that we're returning Fahrenheit when we wanted to return something else. So you want to make sure you're looking carefully when you're doing correct return statements. This would take in a Fahrenheit and return the exact same value. Another typical mistake is to forget to put a return statement. So this one has a missing return statement, and I guess we'd want to return the feet here. So feet equals steps to feet. And yours is not going to have a glaring hashtag that shows you that you forgot to return. So really look over your programs carefully. And sometimes you fail to return a value for a function. So it's going to return none, and then you'll have different consequences from your program than expected. The 6.9.1 challenge activity is not to actually create any errors, but to create correct functions. So here you're looking at function errors and making sure that you're making this a correct function when you make it. 6.10 I've already talked about. When I'm looking at a variable here, the variable total inches is only defined inside of the function here. So the scope is what they're saying is within that function. So that makes the total inches and the centimeters here actually local variables. A variable that you want to use throughout the entire program is called a global variable. So global variable, like employee name here, is first assigned a value, and anywhere you see employee name, it'll be used, except in this one, in the definition function, this only uses local variables. So if you're going to use a global variable, you're going to have to use the global keyword here to change the value of the employee name within your function definition. The global statement must be used within any function where you're assigning values, though you can for mutable global variables like dictionaries and lists. You don't have to require, it doesn't require a global statement if you're adding or removing elements from that kind of container. That's for the mutables. Remember that a tuple is not mutable, it's immutable. So you would have to have the global there if you're going to redefine a tuple. It's really good practice to limit the use of global variables. So unless you definitely know something is going to be assigned the same variable forever. For instance, if you said a person's height and they're an adult, you're going to want their height assigned to that variable forever. There's no need to use the global variable. But it is helpful if you're wanting to use variables within functions. 6.11 describes what a namespace is. It's just a map. It looks a lot like a dictionary. You have a key and a value. There are a few functions that you'll be able to use to get locals and globals from the code that you're writing. So 6.11.1 uses the globals to get the namespace names. You can go back to your programs that you've already written and print in the print globals and print locals to see what you've done in previous programs. There are three different kinds of scopes, really. The built-in scope, where we already have the functions that Python has made for us, and the global scopes, where we have a globally defined name outside of any function, and then the local scope. When you use a name in the code, it's going to check first in the local scope, and then in the global, and then in the built-in scope. So you want to make sure you're not using names for things that aren't already built in. If it can't be found, then it's going to generate a name error. At the bottom of 6.11, they make a comment here that there's actually another level of scope where you could have a function defined in a function. So they're omitting that for clarity. So all your exercises were over the local, global, and built-in. In 6.12, they're talking about function arguments and mutability, whether or not you can change those arguments. So when you pass, like Timmy's age is passed here into birthday, so you pass by assignment, and now the age here is what Timmy's age was, which is 7, then age becomes 8. But it didn't affect Timmy's age. So you have a new object that was created here, and it doesn't affect Timmy's age unless you actually return it. And here we didn't. Understanding the mutability of a particular argument that you're sending, in this case, the parameter that we get is my list. It happens to be a mutable one in here because it's a list, and lists are mutable. Strings are not mutable, and tuples are not mutable. But lists are mutable, so you can change this, and this will be changed outside of the function scope. So it's important to understand immutable and mutable here. So if you don't want to change it, the object globally, like in case of a list, if you don't want to change it, then you're going to pass the list with a copy. So this brackets with a colon in here means you're going to pass a copy of the list. You're going to do just that stuff in the function, and whatever is done in the function stays in the function. So when you go to the next line, it doesn't contain the 99 that you updated in the function because you passed a copy instead of the actual object of the list. In 6.12.1, we introduced two methods, string methods, split and strip. Notice the dot split. That means it's a method instead of a function. So we have some input string that's coming in, and it's being split, and it's being split into name and grade, and then those two things are being put into students' grades. Here, student grades is a dictionary, so the name going in would be the key, and the grade would be the value. They're asking you to fix quite a few items in this program. So there's a while that is getting input from the user. And if the command is not equal to 1, is equal to 1, it adds the grade. If it's 2, then it's going to delete, just like it says in this menu here. And it's going to print, and 4 is going to quit. So it's going to continue asking them for a number. So the command equals input lower strip. So it's going to take their input to lowercase, and it's going to strip off all the white spaces. Quite a bit of what you need to do for these functions is included in the elif statements here, in the elif portions here. So you want to make sure that you copy this into your function before you delete it out. In 6.12.1, we want to define a function that swaps the last and first elements of a list. Now the list is coming in as just an input string, and in this case we want the input string to be elements separated by commas. So numbers, or in this case it was all good things, separated by commas. The split is typically separated by spaces, but this one is showing you a different way that you can use the split, so you don't have to have spaces separating it. This is going to put the list into values list, and then you want to go swap that. Since the list is mutable, what I do in the function is going to update my values list. So first I need my definition. I need to define my function, and it needs to be values swap values list. And here I do want to keep the same parameter name. So I'm going to take my first one and put it into my last one, and my last one in my first one. So I'm going to put a dummy variable. So I'm going to call it A, and we'll just set it equal to the first one. So that's values list. And it's bracket 0. That would be my first one. Now I'm going to put my last one in the first one. Since I've saved my first one, that's what this one does. Hashtag this one saves the first entry. Element, actually. then I can write my last element into my first one. So now I want values list 0 to be my last one, equals values list. And I guess I need the length of the list here, -1. Length of values list -1, because remember the length goes, it starts with a 0. 0 to the length -1 is what we're doing for the indices. And a bracket to complete it. So now I've set my values list 0 to be that. Now I can set my values list, the last one, to be the A. So values list, the last one, will be equal to A. I don't have to return anything here because this list is mutable. So we'll run it and see if it works. And it didn't work because I made a typical mistake that I usually do. The length of values list is one variable, and then I'm subtracting 1 from that. And the length of value list -1 needs there too. And I still need length. Try it again. And that ran correctly. So all the tests pass. So if they gave me gazillion is more than quadrillion, it puts out quadrillion is more than gazillion. So here, this was a mutable list, and I changed values within the list within the function. The lesson here for me is that I really need to be more careful when I'm working with the length of values list. The index here is the length of the values list -1. In 6.13, we note that the keyword argument list could be incredibly long. So when we print a book description, we might need to send a whole bunch of stuff into the function to actually print that book description. So what we're going to do is use keyword arguments that allow arguments to be mapped to parameters. When we use keyword arguments, the argument list doesn't have to be in a specific order either. So it gives us a little more freedom when we're writing our code. So here title is the parameter in my function. Publisher is the parameter, and it's not the second one. I do have to include the entire list, however, so make sure that when you're using keyword arguments that you include the entire list that is needed for the function. The rule, sort of the loose rule, is that if you have more than 4 arguments, like here, there's 4. If you have more than 4 arguments, you want to use, it's a good practice to use keyword arguments. If you're going to mix them, you can mix them, but if you're going to mix them, you want to make sure that the ones that you have in place, like the amount here, is first. And then any of the rest of them, really doesn't matter what order those are in, but those are last. If you, common error is to replace the keyword arguments before all the position arguments, which generates an exception. Which would mean if I put all these before that 125, you'd have an exception there. You could set a default parameter value, and then you don't have to include all of the values that you need in your arguments. So here I want the default to be American. Here it's American. Style 0 is American. Unless the other style is given, style 1, I'll use the American style. So you could set style equal to a default, and then you don't have to include that in your parameter list, in your argument list for your function calls. Note that if you are going to put default parameters, those should be at the end of your list. So here, if you're going to put one default parameter, you need to have that one at the end of your list of parameters. If you want 2, you want those at the last 2, and so on. You cannot make a mutable object a default parameter. So a list or a dictionary can't be a default. If you use a list as a default value here, you can have quite different results depending upon what you defined it to be. So this first one here has an empty list, and then it updates that list. And you can get away with that one. The second one says the list is none, and every time that you come into here, it starts with the list that's none, and it doesn't update the list that you had before. That might not be what you were expecting. So you want to be careful when you're using a default value of a list. I would recommend not using it. So if you have keyword default parameters for every parameter in your function, you can get away with just putting some specific ones that you want to change in your main code. So in 6.13.2 challenge activity, I want to be able to use a function called number of pennies with either dollars or pennies or both. With dollars, pennies, or just dollars. So I want one definition, number of pennies, and it looks like I want to put the dollars first and the pennies second, equals 0. So I definitely want a return value. I want the number of pennies returned, total number of pennies given number of dollars, and optionally a number of pennies. So I'm really just returning 100 times dollars plus pennies. And I put returning, so return. Return is the actual keyword. We'll run that, see if it works. And that worked beautifully.